Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, today our topic is about mass transport, saturated and saturated. Mainly, we will be talking about the saturated media presently, and later on we will discuss unsaturated as well. It is about the movement of contaminant and any kind of mass within a medium. So that medium can be soil, that medium can be groundwater. So we have a different mechanism for movement of contaminant within the soil particles, and then within the groundwater its movement is different. We will try to find out what are the major parameters which influence the movement of mass in a typical environment, in a typical medium. For its further details, we must have a clear idea what is what we normally call and how we represent it. Normally, we have solutes, solvents. So, what are the solutes? So, these are the particles which are being dissolved in a typical environment, in a typical solution, in a typical medium. Similarly, what is a solvent? A solvent is something in which it is being dissolved, in which is giving it the form of a solution. So basically, solutes are dissolved in the solvents. That's why water is considered as the universal solvent. Now the solutes vary in their characteristics. They can be reactive, they can be non-reactive. And what defines their reaction is their properties and their behavior with the solvent, how it is going to react. So sometimes the solutes are reactive. So what is the definition of reactive? It means that they immediately get dissolved, they exchange ions, they completely change their ionic condition, and they develop new bonds, and they shift their valency numbers, they shift their ionic status. So all these things are making them reactive. So such compounds, such solutes are normally declared as non-conservative. While we have a conservative solute which is non-reactive, how it is going to behave in a typical medium and how reactive and non-conservative solute is going to behave in a typical medium. It is a totally different mechanisms. So, if we talk about conservative, non-reactive, how it will react with the water which is present in the pores, in the soil, in the voids. So, because it is conservative, it is not going to react. So, it will exist in the system, it will exist in the water in the water phase. It will exist in the water phase, and if it is uh, passing through some soil medium, then it is quite possible that it can be trapped, but there is no other way that it will be getting contained in that environment. It is not going to be it will not retain in the soil, it will be departed, it will move on, and it will move on to the groundwater. It will join the aquifers and it will move forward, but it will not stay in the system. But if it is reactive, if it is has the capacity to get dissolved in the soil, sorry, in the aqueous phase, then in that case it will again get dissolved in the aqueous phase, and it will have a much more mobility. At the same time, there is a possibility if it comes into contact with the solid particle of the soil, then it can have a reaction. So this is a difference between non-reactive and reactive solutes. So let me simplify. The reactive compounds, if they are getting attached, they have two possibilities. Firstly, they will get dissolved in the aqueous phase, and then they can move forward. And second possibility is this, that they can uh, get attached with the solid particle of soil, and in that case it will be retained within the soil. We will take an example of it later on. But now, just for the sake of information, if we consider clay as a negative charged particle, and if we consider chromium in the source, in the pollution, in the water penetrating into the soil with positive ion cations, then that chromium has more capacity to get attached with the solid particle of soil, which is called clay. So it will be retained in that part. And if it is not reactive, it is not going to uh, add up with the solid particle. The second option is, it is called non-reactive, and in that case it will be in the aqueous phase, and that aqueous phase is in the pores, and that pores have the water, and it will carry that charged particle along with its movement down into the active parts. So then we have concentration of contaminant solute, which is held adsorbed on the solid phase. So can you differentiate between adsorbed and absorbed? So what is absorbed? Absorbed means to completely dissolve, to completely uh, uh, um, deform and completely develop into a new form once it is getting dissolved and or attached with source. Adsorbed is only on the surface. So adsorption is a kind of physical process, while absorption is a chemical process. So CS is the concentration of mass of contaminant in unit mass of soil grain. So what is that soil grain? It can be clay, it can be sand, it can be silt. So that is going to define the fate of a contaminant in a typical environment, and that's the um basics which will define the solution to a contaminated site. So if we are going to clean out a contaminated site, we must understand what kind of contaminants are there and what kind of soil particles are there, what kind of geological formation is there, which is reacting, which is developing different kinds of scenarios, especially regarding retainment of the contaminant, and especially regarding the dissolved form of the contaminant in the aqueous phase, which is carrying it forward to the aquifer and helping it moving to the further distances. So this is a very important uh, um, understanding about the solutes and their nature and their behavior with the medium, whether it is soil or whether it is groundwater. If we have a porous medium, it will be containing solid phase. So that solid phase is actually the soil grains, as we talked about it. It is called clay, it is called silt, it is called sand, it can be anything. And then it has a white space. This white space is, in saturated case, completely filled up with water. And in case of unsaturated, it is partially filled with water. Remaining is air. So, and then we can have, so it's kind of repetition, how we are going to measure this concentration which is attached with the solid particle. Solid particle is the clay, silt or sand part component of the soil. Soil is the volume. Solid particle is the typical component of which it is formed, like silt, clay or sand, or its mixture. And then we have a third thing which is called white space. So that is going to define what our medium is constituting of. CS is actually giving us the mass of contaminant in units of soil grain, and it is normally measured in milligrams per kg of the soil volume, mg of the concentration of the solute. So when we are talking about the uh, soil pollution, we are more concerned with this value rather than the amount of the solute which is present in the aqueous phase, white space. So we are more concerned with this part rather than this part. What is the reason? Because this part is going to be retained and this part is going to move forward. And this part is more important regarding the groundwater contamination. And this part is more important with respect to the soil pollution, soil contamination. So that's how we can describe the medium and the importance of their particle nature, their soil texture. So soil texture is based on their components like silt, clay or sand. So again, taking the example of chromium being the positively charged particle, it is going to be attached with the clay particle which is negatively charged, anionic. So in this case, we will be having more chances of the contamination. If our soil medium, is dominating with clay, it means the chromium has more capacity to get retained in that soil. So soil contamination is the major. And then if we have some other ionic ionic source of contamination like arsenic uh, or some other like chlorides or anything which is anionic, that is not going to be attached with the solid particle of soil, but that will be absorbed in the aqueous phase. So what is the significance of this absorption? It will carry this contamination to the groundwaters. So in that case, we are more concerned with the uh, groundwater pollution. The major impact of soil contamination is related with our soil utilization, land utilization. If we are going to use that land for agriculture purpose, we are more concerned about their soil pollution because that is directly contacted with our root zone, and then the movement of the contaminant through that root zone and getting into the plant and being carried forward to the humans. So in that case, we are more concerned with the soil contamination. But if it is in the aqueous phase, we are concerned with the groundwaters, and groundwater has a multi-purpose usage, for example, for drinking purpose, for other domestic usage, and for agriculture purpose. So again, we are concerned based on their usage. So that's going to differentiate their significance. And at the same time, if we change the content, if we change the soil medium, if we change this solid particle, if we change this soil grain, what will happen? If we shift it from clay to sand, sand is not having any charged particle. It is not going to have any retention property. It has no retention capacity. All the chromium will not be absorbed with this soil grain because it is sand. So if the soil medium is constituting sand particles, then we are not having any kind of soil contamination in that part. So where in that case, most of the contaminants will be dissolved in the aqueous phase here, and it will be carried to the groundwaters. Then groundwater is the major risk, not the soil. If the soil medium is mainly constituting sand particles because they don't have any capacity. Similarly, if we have some boulders, if we have some silt particles, it will be decreasing the possibility of the if, of the retention. So, summarizing this whole discussion, we are having two kinds of phenomena which are important to us regarding the this contaminated site assessments, and that is mobility and retention. Mobility is the movement of water through the aqueous phase, through the pores, and retention is all based on the contaminant being attached to the soil particles and being attached with this solid phase, attached with this soil grain. So these are the two behaviors which are important to us, which we need to study. Our all the discussion related to the fate of a contaminant is all based on these two phenomena, mobility and secondly retention. So, moving forward, we will now try to understand how these phenomena can be associated in different kinds of medium. Next, we can have their scale. For example, microscopic scale is actually studying the contaminant at a pore volume scale. So it is the very minute level of study. Then we have mesoscopic scale. Here we are going to involve the specimen at the laboratory based studies. Then we have a macroscopic scale. So in this case, our scope is larger, we have more area to consider and more parameters involved while studying macroscopic scale level studies for the rate of contaminant. As far as microscopic scale is concerned, we are only concerned with this pore volume of the soil and then this grain size. Only this level which we are studying. Then this is second one is the mesoscopic scale in which we are having a very controlled environment. We can control all the parameters which we are going to study. While in this case, everything is dependent upon the availability of the different conditions in the field. So what are the key contaminant properties for flow? Miscibility. So what is the miscibility? It is the property because of which any kind of solute can get mixed with the water. So if miscible, extent to which it mixes with water, if miscible and high, so if miscible and high enough uh, hydraulic activity, contaminant will move with the water by advection. So what is advection? It is the movement with the flow. So flow of the solute with the groundwater flow. Very simple. So we have easy permeability, ease with which the water is moving. It is, and both the conditions are facilitating the movement, and it is first of all mixable, and then it has a high conductivity. The contaminant will move with the water. Very simple. If it is mixable and low K, the diffusion will be flow mechanism. We do not have easy path to move, rather there are some interlockings within the soil, and how in the water, how the contaminant will behave in this kind of scenario, it will be all based on the diffusion process. What is diffusion? The movement of contaminant will be based on the concentration gradient. So if we have a concentration gradient, then between two different positions, the contaminant will move from higher concentration to lower concentration. So this is the possibility when we have low permeability levels, low hydroactivity. But the contaminant is already there. It is mixed with the water. Then density is another important property which will be defining it. If miscible, behavior will depend on the density to some degree. So density is again one of the parameters which need to be addressed in this case. And particularly the importance of density is related with the diffusion process. So some contaminants float on top of the saturated zone based on their density. So what kind of scenario this can cause? So this is the scenario in which our contaminant, in which our solute is having volatile nature, and it is supposed its density is lesser than water. What will happen? It will stay on the surface of the water, and it is not going to get mixed with the it will not flow with the water, but it will flow with the top surface only, because it is lighter in density. It is just like a layer of oil floating on the surface of water. That contaminant is not penetrating down into the bottom of the container of water. It is not going to mix with water, but it is going to float on the surface of water. So that's the importance of the density. So some sink through and may move down gradient along the impermeable layers, and in this case it's a more case with the higher densities, which are density driven. They are because of their higher densities settle and make their way based on their uh, density and their specific weight, and it will not follow the groundwater flow direction, but it will so in most of the cases we have this kind of behavior. Most of the cases the contaminant is not going to travel longer distances. In the first case, the contaminant is floating on the surface. It is a shallow contamination, but it is a long duration, long distance contamination. The contaminant is going to be carried to the longer distances if it is having lighter density. So in this case, even we have sorry, if the medium is facilitating the water in some other direction, normally the surface will be the contaminant will be on the surface, while in this case it is going to dump at one place if we have higher density contaminants. Most of the cases, if you study Naples, what are Naples? Naples are non-aqueous phase liquids. So mostly in that case, this is very important parameter to be considered. So Naples are of two kinds, with lighter weight and with higher weight, higher densities. We will discuss them later on, but here just for the sake of information, Naples are going to be one of the important factors, uh, examples for the case of studying this density movement. Solubility again, degree to which contaminant dissolves in groundwater. Volatility is again dependent with the help of this. Most of the water can exist in the upper layers and maybe in the unsaturated zone as well. Sorption characteristic is important. So degree to which contaminant adsorbs or dissolves from the aquifer material. So what is sorption? What is desorption? Sorption is actually the process in which the contaminant is getting adsorbed on the surface of the solid particle of the soil volume. If it is getting detached from the solid particle of soil, it is called desorption. If it is getting attached with the soil particle, it is called sorption. So it is a very important characteristic, and in our all the studies related to the contaminant and its movement, this kind of this parameter is very important in defining which methodology need to be adopted to decontaminate our soil medium. So here is another example. Contaminant transport needs to understand mass or solute transport, groundwater flow, continuous source, and so in this case we will be getting this plume. This plume is actually like the concentration gradient difference. So for example, if this is the source of contamination, this is a point where we are having uh, continuous origination of the source of contamination, and the flow is in this direction. We will be having minimum concentration on this level and the maximum on this level, and in between we will be having different contours of different concentration. So every contour will be called a plume, 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 and uh, and every plume, every contour will be continuously changing its concentration because we are having a continuous source here, and it will be continuously. So this contamination is actually going to be shifted to this level. So at one stage, at one time frame, all this concentration will be equal to this concentration, and that time we will be having same contour throughout. But initially it will be having this value. It's only if we stop it here. But actually this groundwater is flowing, so this point is being carried forward and forward and forward. So that's why we will always have a plume, and every plume is having a contour of our typical concentration. So this is the case with a continuous source and with a continuous groundwater flow. If we have only one time source and the flow is in this direction, then this cluster is going to be shifted here and here and move on, and with every change in time and every change in location, concentration will be continuously changing. Every next move will reduce the concentration of dilution, and here it will also dilute because the contamination is no more existing, it has stopped. So this is the contamination plume development. So what are the processes of having this movement as shown here? What is the process? How we can evaluate it? How we can determine that this much contamination has spread? It depends upon different factors, and it has different mechanisms of movement. These are the different processes which actually define the movement of contaminant under different conditions. First of all, let's talk about the physical processes controlling flux, and we have advection, we have diffusion, we have dispersion. So, what is advection? It is the solutes carried along by flowing groundwater. Very simple. So, this advection means that the solute is being transported from one place to the other along with the groundwater flow. There is nothing else, no other parameter or factor is influencing this movement. So, another process is diffusion, in which transport of contaminant is taking place by molecular diffusion, concentration gradient. And this takes place when we have interlocking, when we have difficult path, the path is tortuous, and normally the only option left for the contaminant transport is the concentration gradient. We will discuss it in detail in the coming slides. But here we are going to understand that this process is only applicable at those complicated structures, those complicated geological formations which do not facilitate the movement of water, which do not facilitate a smooth path for the flow. The connected, interconnected pores are not so effective. The water cannot travel with because of the interconnected pores, but it has only one way, and that is the uh, difference in the concentration. Then we have dispersion mechanism. So in some cases, we will be having a mechanical mechanism of the mixing. So in this case, we will have a much more complicated phenomena, and that is called dispersion. This dispersion can be because of, again, the differences in the in the geological formation, which we cannot even have this diffusion, but we can have a difference in the soil texture, and because of that soil texture difference, the water will, for example, if we quickly shift from the silt to sand, we are actually providing a smoother path to move. And wherever there will be sand, there will be automatically a path generated for the particle to continue moving in that direction. So it is kind of dispersion based on the uh, available conditions. So wherever we will be having a more dispersion, there will be a much more heterogeneous phenomena existing in the soil layers. So this is the advection, which is the transport process, and the process by which solutes are transported by the bulk of motion of flowing groundwater. Non-reactive solutes are carried at an average rate equal to the average linear velocity of the water. So simple. Only the non-reactive solutes which are existing in the liquid phase, aqueous phase, and that aqueous phase is in the pores of volume, pores of the soil volume. So this water will be carried along, this contaminant solute will be carried along with the water without any disturbance and equal to the average linear velocity. Average linear velocity, we earlier in the previous lecture we talked about it while discussing Darcy law. Then we have a hydrodynamic dispersion. So it is based on the water movement, water dynamics. And what kind of movement this is? This is the diffusion, molecular, and dispersion, which is mechanical, and it is because of the change in the soil layers. So here you can see what other factors can affect. So like this advection and dispersion, we can have these activities, these processes, chemical bar processes, acid-base reactions, solution volatilization, precipitation, complexation. All these are the processes which are simultaneously taking place based on the soil texture available in this medium. So if there is a chemical reaction taking place, so for example cations and anions are making a bond, then it will automatically affect the movement of the contaminant or solute. Similarly, hydrolysis process, isotopic reactions, and then oxidation reduction reactions. All these things are facilitating the movement, but in its own way. So this is the advection, and I think this topic we will start in the next lecture, and we will talk about it in detail. For today, we will stop it here. Before going into the details of the advection and then dispersion, then diffusion and then dispersion, we will simply close here, and next time we will talk about it in further detail. Thank you.